All right, so here we are. We're going to go ahead and move on to operations on polynomials. We're still in Unit 1 material. And when we start on operations with polynomial, operations means we're doing something with them, right? We're adding, we're subtracting, we're multiplying, we're dividing, those types of things. So we always want to complete the operation and then simplify by combining like terms, okay? So don't just do the operation and then stop. You might be able to go further. Okay, so on these first examples, we want to just perform the operation that's indicated and then simplify. So notice on these, it's saying we're taking this polynomial and we're adding it to this polynomial. Now, when we're adding, we don't actually need these parentheses to show us here's the first polynomial and here's the second polynomial. We can just drop those parentheses and combine like terms. So we have 5x squared minus 6x plus 1 plus 7 minus 2x plus 7x squared plus 4x cubed. Okay, so once we drop those parentheses, we have everything right now. Now we're just looking for terms that match or like terms, meaning they have the same variables raised to the same powers. So here, our highest power of x is our 4x cubed, right? So we're going to go ahead and write 4x cubed. Then we move down to x squared. We have a 5x squared and we have a 7x squared, which gives us 12x squared, right? And then we move down to our x's. So notice here I have a negative 6x and I have a negative 2x. So negative 6 and negative 2 gives me negative 8x. And then the last thing we have to do is just combine our our constants. So positive 1 and positive 7 gives us a positive 8. So that's as simplified as we're going to get it for the purposes of this class for right now. Okay, so easy enough. So let's look at another one. Let's look at one where we are subtracting. So here, these parentheses actually kind of do make a difference. If we have this polynomial and it's subtracting this other polynomial, basically that means we're subtracting every single term of that second polynomial. So if we're subtracting every single term, we need to make sure that this little subtraction symbol gets distributed to every single term. Now you can think of that as multiplying by a negative 1, or you can think about it when we're subtracting, it's like adding the opposite. So what that negative is going to do is it's going to change the signs of all these terms. Okay, so I'm going to go ahead and write this first polynomial. I'm going to drop the parentheses on it. Negative x squared minus 16x plus 8. And then when I distribute that negative by multiplying by a negative 1 or just flipping the signs, I'm going to end up with a positive 7, a positive 2x, a negative x squared, and a positive 5x cubed. Okay, so now that I've distributed that negative through the whole second polynomial, now I can go ahead and combine like terms, okay? So don't start combining like terms until you've taken care of that subtraction, right? So again, my highest degree term here is an x cubed. So I'm going to start with my 5x cubed. Then I go down to x squared. I have a negative x squared and a negative x squared, which when I combine those gives me negative 2x squared. Okay, and then I look at my x terms, negative 16 plus 2 leaves me with a negative 14x. And then I combine my constant terms, which is a positive 8 and a positive 7, which gives me a positive 15. And we're just going to leave it like that. Okay, not too bad, maybe, hopefully. All right, let's look at a couple more. So that was addition and subtraction. Now I want to focus a little bit more on multiplication. I'm going to do 3 examples of multiplication, and then I'll give y'all some to try. All right. So when we're multiplying, some of you may have learned a strategy called FOIL. Okay, that's fine when you have a binomial times a binomial, but when you get into a binomial times a trinomial or anything bigger, FOIL no longer works. So instead of saying foiling it, we're going to say distributing. And when we distribute, we're multiplying every term of the first polynomial by every term of the second polynomial. Okay, so I'm going to write here distribute. This should be a little bit of review from your last math class or possibly even the class that you had when you were in high school. So we're going to start with this 8x. And we're going to do 8x times 8x. So 8 times 8 is 64. X times x is x squared. Okay. Then I want to take that 8x and distribute it over to this negative 1. So 8x times negative 1 is negative 8x. Okay, so I've distributed this 8x. I'm all done with it. So I move on to the next term. So now I'm going to do 1 times 8x, which is going to give me a positive 8x, right? And I already have an x term, so just to make my life a little bit easier, I'm going to go ahead and just stack these, and that way it makes them easier for me to combine later. If you want to keep just writing them out in a straight line, that's fine too, okay? And then I'm going to do 1 times -1, which gives me -1, okay? So then I just combine my like terms, which since I stacked them, it's pretty easy to see I have a -8 and a +8. Then those are actually just going to cancel out, right? They're opposites. And so I'm left with 64x squared minus 1. And I just leave it like that, okay? All right, let's look at a little bit bigger one. So now we're doing a binomial times a trinomial, but the same strategy applies. We're still just taking each term and distributing it through the second polynomial. So I'm going to do 4x times 2x squared. So 4 times 2 is 8. X times x squared is x cubed. 4x now distributes over to -5x. So 4 times -5 is -20. And x times x is x squared. Okay. Then I do my 4x times my -4. So move it over. 4x times -4 gives me -16x. Okay, so I fully distributed this 4x. I'm done with it. Now I move on to my -7. -7 times 2x squared is going to give me -14x squared. And since I already have an x squared here, I'm going to just line it up. So -14x squared, and then -7 times -5x. -7 times -5 is +35, and we have an x, so +35x. And then I distribute my -7 over to my -4. -7 times -4 is +28. So now that I have it all distributed out, I've multiplied it all out, now all I have left to do is combine like terms. And since I have it stacked, it makes it pretty easy. So I have my 8x cubed, -20 and -14 gives me -34x squared. -16 and 35 leaves me with a +19x. And then my +28 for my constant term. Okay. Not so bad. Let's try one more. And this one more looks super easy, but it's the one that everybody makes the most mistakes on. And so I'm going to give you an example of it so that you don't fall victim to the mistake fairy here. Okay. All right. So this is the same thing as what we've been doing. It's just written in a different form. So what we have is we have a quantity squared. And remember back when we were talking about exponents, exponents represent repeated multiplication. And so what this is actually representing is this is representing the quantity 5x minus 3 times itself with 2 copies, okay? So the biggest mistake that everyone makes is they want to just square the 5x and they want to just square the 3, and that's not correct because you're going to be missing out on some terms, okay? Anytime you see an exponent, you want to make sure you write that out as repeated multiplication. And now we can go ahead and distribute this, or in this case, FOIL it, right, to get all of our terms. So 5x times 5x is going to give me 25x squared. 5x times -3 is going to give me -15x. And then I distribute my -3. -3 times 5x is -15x. So again, I'm going to go ahead and just line mine up. And then -3 times -3 is +9. So I'm just going to combine my like terms now that I have it all multiplied out, which gives me 25x squared minus 30x plus 9. And I just leave it like that. Okay, not too bad. All right, so there are 4 here for you to try, and I will leave them up here. And I want you to pause the video and multiply, subtract, add whatever the operation that's indicated. Perform the indicated operation and completely simplify your answer. And then here in just a second, we'll go over them. Okay, good luck. All right, so we're going to go ahead and go over these, and I'm sorry my paper kind of has some glare on it. I'll see if I can fix that. So on number 1, all we're doing is subtracting. We're not actually multiplying. We're just subtracting. So remember, when we subtract, we take that subtraction, we distribute it to every single term in that second polynomial, which is going to change all their signs. So we end up with a -2, a -5x, a positive x squared, and a positive x cubed. And then from there, we're just combining like terms. Okay, so if you did this one correctly, you should have ended up with x cubed plus 4x squared minus 10x minus 4. Okay, if not, go ahead and pause the video and rework it. Fix your mistakes, okay? All right, number two, this is a straightforward multiplication. So again, we're starting off with -3x and distributing it to both, and then doing our -3 and distributing it to both. Once you combine your like terms, you should get -15x squared minus 21x minus 6. Now, whether you stacked yours like this or you wrote it out as one long line of terms, if you didn't get this answer, just double check your terms with my terms to make sure that you got the same sign, the same power of x, and things like that, okay? All right, number 3, same idea, still just distributing. This time it's a binomial times a trinomial. So I went ahead and distributed the 4x to everything and then the -4 to everything. So I have 2 lines, right? And when I combined, we get -4x cubed minus 16x squared plus 28x minus 16. Okay, again, if you're finding an error, pause the video and find your mistake and correct it. Okay, it's how we get better. All right, and then the very last one was a squared one, like the one I had worked similarly. So when we have 2x plus 7 quantity squared, that means we have 2x plus 7 times itself, 2x plus 7. And then we go ahead and distribute our 2x and our 7 to that second binomial, okay? So here we should end up with 4x squared plus 28x plus 49. All right, so that is the end of operations on polynomials. So you should now be able to complete that assignment. If you have any questions, let me know, and we'll see you on the next video.